Hello, for my project, I wanted to show you how chemistry is involved in making candy, specifically those caramel apple lollipops you see during Halloween. I chose this because sugar is extremely reactive to heat and even cold temperatures. Those are the ingredients we will be using, and you want to start off by getting 2 cups of sugar, 2/3 a cup of light corn syrup, and 1/4 a cup of water. Go ahead and pour those into a pot, preferably a pot that you don't really mind getting dirty or even ruining, just because the heat and the sugar will create some crystallization around the sides of the pot. I did not show that you will also need a pot or a bowl bigger than the size of the pot that you're pouring the sugar in, filled with water and ice, and make sure to keep that on the sides of you at all times. You will also need a thermometer, preferably a candy thermometer, but like me, most people don't have those on hand. So any thermometer works, one that reaches at least 310 degrees. I used a meat thermometer. It works fine, just as long as you're able to read the temperatures of at least 310 degrees. Because sugar does have many boiling points, which do affect the consistency of the sugar and the candy that you will be making, we need to reach the consistency of broken glass. So that is also another reason why you need the pot full of ice water, which you can see right there. So now we're going to go ahead and heat up our solution of water, corn syrup, and sugar. And I put it on a medium temperature setting on my stove. And I just started to mix it around and take the initial temperature of it on the stove when we first started. So as you can see, it's around 170 just from that medium heat. So now you're going to see my dog come up on the screen. There she is. She was very curious as to what was going on because the sugar was starting to kind of bubble up and like pop at this point because of the heat. So what we are now going to notice around the sides of the pot, like I had mentioned earlier, is the sugar beginning to crystallize. This is happening due to the high temperatures, and we are beginning to reach that first initial boiling point of sugar. As you can see, it is starting to boil and bubble up on the sides. So now that we are noticing that the solution is coming to a boil, we are going to take another temperature just to get an estimate as to where we are in the boiling point of the sugar. You will notice in this video that we are going to be taking the temperature many times because sugar is extremely reactive to heat, and that can really affect the consistency of how your candy will come out. So as you can see here, we are getting a little bit closer to the bubbly, boiling consistency that we need the sugar to become. So now I am going to take another reading because this is what we want it to look like, but we do need that sugar to reach that temperature of at least 310. Because if not, when we essentially get that sugar to the freezing point, it will become chewy and not super solid. And then you will begin to notice that the crystallization of the sugar has stopped because it has reached this boiling point. Of course, there is still some of that residue around the sides of the pot, but the crystallization of sugar has stopped. And now that we're reaching the higher temperatures, getting up there in the 200s, close to 310, we are going to start getting everything ready. So I'm right here, I'm getting some citric acid ready, getting my caramels ready as well, so that way we can dip them in there. You do have to use soft caramels because they won't stick to the lollipop correctly. And then here we are taking another temperature check. And right here, it is kind of hard to see. I don't know if you can see it very lightly, like little tiny hair shining. That is essentially like what happens to cotton candy. It kind of starts to get into this thin, like hair-like structure because the sugar is reaching such high temperatures. And so when I am taking the thermometer in and out, it is kind of creating that motion to where it creates a cotton candy-like texture. And as you can see here, we are reaching those higher temperatures. You do have to be careful that, the thermometer isn't touching the bottom of the pot. You need it to be kind of in between that solution, because if it does reach the bottom of the pot, it will be a different temperature. Right here, I am getting a little bit of our solution and essentially rapidly freezing it over the ice. And I just want to see if it's gonna break like glass because we want that consistency and that texture. So there it is. You can see it does look like glass, and then I'm going to try to break it. I do not need it to be, soft. I need it to easily break and crack. And then, of course, I am taking another temperature reading. I also did just want to show you that if you are not using a candy thermometer, it's not going to give you the exact temperature reading right away. You're not going to get that reading, you know, within seconds like you would a candy thermometer. So as you can see here, we are reaching the 300s. I also did want to note that right here, I made a bit of a mistake. Since we are in the 300s, it would reach that 310 temperature pretty quick. So I should have prepared, you know, the coloring, the flavoring, as well as the other inclusions that I'm going to add inside of the solution. And then I am sorry if you can hear background noise. My little sister is playing right now. You will see her at the end of the video trying our lollipops. I also did just want to mention that I will be including more in-depth explanations as to how this ties into chemistry on my slideshow, but for the sake of the time of the video, I won't be going as in-depth. I will just be showing you like the boiling points, the freezing points, as well as you will see that there are some gas creating reactions. I don't know if you can see it right here right now, but since we are reaching those 300 temperatures, there is some gas forming. I also did forget to mention that this is in Fahrenheit if you can't see, but also in my slideshow I will be including the conversions from Fahrenheit to Celsius and as well to Kelvin. And right here we are reaching that temperature of almost 310. You'll see it right now jump to 311, which is fine, but we just do not want to go excessively over 310. So I am going to go ahead and put that in the bowl of ice water so it can kind of cool down a little bit. I will also be explaining in depth in my slideshow why this needs to happen. But I'm just going to keep it here for about 10 to 15 seconds, maybe less than that. And now I'm going to include my citric acid, my flavoring. These will all be in teaspoons. I did do a teaspoon of the citric acid, a teaspoon of the flavoring. I think it was a teaspoon and a half, I'm sorry, of the flavoring. And then a couple drops of our food coloring. And you will see how it's forming gas right now. And then you will also see how the solution begins to bubble when we include the food coloring. And then as you notice, there is gas forming. I do want to say that this was caused by the citric acid that we put in. The stove was not on at this time just because, like I said, I did need that to cool down a little bit before I put it in my mold. So yeah, right here, there is a gas forming reaction. Another thing to note is that it is beginning to change color a little bit. It is starting to get dark. Of course, I had food coloring in it. But before the food coloring, it went from almost like a clear color to this dark yellow. So I am mixing in that food coloring, and as you can see, it is starting to bubble. I did need to look at the ingredients in the food coloring. Maybe that had something to do with it, but I was very intrigued as to why it started bubbling. There was no heat on this. It did just begin to bubble out of nowhere. I also wanted to mention that because of the bubbles forming when we put in the food coloring, it did start to create more gas. I actually would prefer to call it vapor rather than gas, but that vapor started to occur more when we included the food coloring. As you can see, it kind of stopped right there, but now we are going to go ahead and pour it into the mold, and it was super hard because it was a little bit heavy and super hot, so you need to be careful. I would recommend wearing heat resistant gloves. I didn't have any on me. But I did end up burning my hand. I'm okay. No medical attention was needed, but just be careful. All right, so now we have those in our molds. We are going to go ahead and put them into the freezer. I did forget to take a video of me taking a final temperature of the candy solution before I put it into the freezer, but I do have it written down that it was 275. So yeah, I'm gonna go ahead and put those in the freezer. I did need a little bit of help because I was scared I was gonna drop them. And we did set a 2-hour timer, but it was kind of late at night. We got a little hungry, so I went ahead and got some food. So it was a little bit over 2 hours. I want to say maybe 3 to 4 hours that we left them in the freezer, and that was way more than enough for them to reach their freezing point. All right, so here's after we have eaten. I did take them out of the freezer. They were pretty easy to pop out of the mold. I didn't need to put any non-stick or anything, but I am gonna go ahead and melt my caramels. They did kind of melt a little bit when I had initially put them in there, so at this point they were slightly melted, but not melted enough for them to stick to the candies. And then we are going to microwave these at 30-second intervals. As you can see right here, the The caramel was not sticking to the lollipops because it wasn't melted enough and they were still pretty cold. So the cold plus the hot was not letting them stick together. I did keep trying to dip the lollipop in the caramel, thinking that I was doing something wrong, but I just didn't realize that the lollipops were still pretty frozen and the caramel was still not melted enough. I did do this maybe no more than a minute after I pulled them out of the freezer. And then you'll see right here, right now in a little bit, that because I had microwaved the caramel too much, I kind of had the same reaction as when we had initially started boiling the sugar solution. So it is kind of gross looking, but I did go ahead and get a new batch of caramel going. And then obviously by the time that that was done, the lollipops were pretty not frozen anymore, pretty room temp. And so you can see the caramel sticking so much easier, and I did melt it to the correct temperature. I did not take a temperature of the caramel just because I believe that microwaves are pretty inconsistent when it comes to temperature, so I didn't want a super inconsistent temperature reading when I was dipping them in there. And then in just a second, I am going to show you what happens when you take a frozen lollipop and try to eat it right away. The lollipop was pretty frozen, and obviously our mouths are pretty warm. So it did end up cracking the lollipop completely, and I thought I had like broken a tooth, because it sounded like a very loud pop in my mouth. So just be careful if you are making these that you don't put frozen right away into super hot, because it will crack. As you can see right there, it's cracked, it's broken, looks super ugly. And of course, as soon as those are done, I did put those back in the freezer so the caramel could freeze and stick to those lollipops. I left that overnight, and I went ahead and took them out in the morning, and they are done. Here's my little sister trying them. She really liked them. I tried them. They were super good.